Let's start with a quick show of hands, students of philosophy. Who has read Discourse on Method by René Descartes, 1637? An amazing read, Rich and Judy classic. Anyone seen that? You're probably wondering why I'm asking that. Well, the blurb on the back, if you had to flip this over, would say something like a method of conducting one's reason to seek truth in sciences. But it's responsible for a couple of famous quotes. The first one you probably do know is the one that says, "I think, therefore I am." But one of the more obscure ones is it's the first point in literature where there's a reference to the human body basically being a machine. And the reason why I'm mentioning this is because I want to focus a little bit on the brain here. Because the brain is probably the most sophisticated defense system that we have, actually. It's got the ability to perceive, detect, and respond to risks and threats in microseconds. So we see all this amazing tech, the vendors upstairs selling all this stuff and so on. Nothing beats that. So if we're trying to build a defense system, let's say a security operations system, a security operations center for detection and response operations, you could do a lot worse than modeling it on the human brain. Let me give you an example of this. So as you see upstairs, you've got your cyber reasons, your Darktrace, the various different vendors. They're our data sources. If we model that based on the human brain, these are our senses. And as you know, you've got your eyes, your ears, your nose, your taste, and your touch. Okay, your five senses. That is our data that's coming in. If we look at how the human brain processes that, then we've got a big analytics engine that does the processing in real time. It does the calculation in real time. We are able to calculate what's actually happening in real time and correlate that information. And we write that to memory. We have an amazing memory. We're able to use that to decipher learned behavior. If you think of how the human learns, it's based on behavioral learning. And we're doing that based on our memories, the processing that we do, the calculation, the correlation, and then we make decisions. Okay? So if we're able to do this type of operation for our information security, our cyber operations as a security operations center, then we're on the right track. But the last point is the actions. So when we talk about actions, it's actually, we've learned all of these things, we've detected a risk, what we're actually going to do about that. In human terms, that breaks down into responses, and these are a combination of all these things. So if you think about it in the human brain, that is a symphony of thousands, hundreds of thousands of neurons working together to make a conscious decision, okay? And that decision is the response point, okay? As opposed to a reflex, which is like a knee-jerk reaction. Something which is fully automated. The brain doesn't even come into the picture here. It's completely involuntary. So if you're looking at building a security operations center, this is a good place to start because we want to do all of these things, but we want to substitute all these things with proprietary operational speak, okay? So who is running a security operations center at the moment within your organization? Show of hands. Anyone? So we have no one who's doing any sort of detection response at the moment. Okay. So at the end of this, if there's one takeaway, these are some of the things that we need to be able to orchestrate. Now, just as a quick introduction, I'm the Security Operations Center Director for SI. I operate 5 security operations centers globally, about 170 analysts that report into me on a daily basis, and hundreds of customers across lots of different industry verticals. So we see an awful lot. There's a lot of investment in technology with a lot of, often we forget to make sure that we're properly configuring things, making sure we're getting the best value out of the things that we do deploy. So I want to go back to the basics. So if I take this slide here with the data and I substitute that with what we need in terms of data sources, obviously the first thing is event logs. Okay? This for me is hearing. And the reason why it's hearing is because these are the log messages that I'm getting from my firewalls, proxies, servers, Active Directory, malware reporting systems that are telling me that something is wrong. Okay, we've got to take that information. I don't actually see the actual root cause. The log message says, I've got an object access failure, an access failure. I've got a particular malware event, a denied event on a firewall. I trust the log. I use the log. Okay, so it's hearing in this analogy. as opposed to sight, which is more around what you've just seen in terms of EDR tooling. We need that as well, okay? So seeing is believing. We see the processes that are executing, the binaries that are executing, the command lines. That's sight. You combine event logs with EDR tooling to be able to actually see what's happening on those endpoints. So we're starting to build up the layers. What we'd add in next is pretty much around the tactile stuff, okay? So I want to be able to put context around all of those things. I see a malware event or I see a rogue user behavior. I want to be able to validate that. I need context for this. So context can be many things, but it can be intelligence, it can be vulnerabilities in terms of the system vulnerabilities that you have, looking at the actual assets in terms of the priority, the criticality of those assets, user behavioral scoring mechanisms. These are tactile things that you can say, you can add context to your environment. One of the most beneficial ones is to identify what are your critical business systems and identify security events associated with those. We'll come on to that in just a second. And then finally, what I would say network behavior analytics, your dark traces, vectors, or even to some extent your IPS signatures, that's your sense of smell. It's looking at the network and saying, this doesn't seem right. There's an anomaly here. I can't actually imply exactly what the root cause is, but my algorithm says it's bad. And if it smells bad, sometimes it is bad. Not always, but sometimes it is. You pull those things together, you've got the source of the data you can start to do analytics on the basis of. Taste, I don't really have anything for taste, but we can, any ideas? We can work on that. So the point is our analytics system, which I've mentioned in terms of the human brain, that takes all of that sensory stimulus from our human senses, turns it into proper actual information. We need to replace with a complete system. And this is not a tool that we're going to replace it with. It's more a system in terms of a combination of people, processes, skills, and technology. Any one of these things you have a gap in, and the whole thing just doesn't work. And people, process, technology, people talk about it all the time. Do we see enough adherence to it? I would say the least important aspect of this is technology. Technology comes and goes. Flavors of technology change over time, but the people don't. And we're trying to do man and machine. So it's super, super important. But addressing the technology stack first, okay? So you need to build a system that allows you to collect and aggregate all of that information from all of our different sensory stimulus and feed it in, make sense of it. So the first problem we've got is around data collection, okay? So what we're pointing towards here is traditional SIM tools. Anyone running a SIM tool here? Okay, all right. Anyone else? No? Okay, so security incident event management tools are analytic systems that allow us to collect, aggregate, and make sense of the information in terms of prioritization of the risks, correlation, machine learning. This is what it looks like. Your data collection layer needs to collect data from anything out there. We've got stuff in the cloud, Azure, AWS, Office 365, maybe some security systems in the cloud, on-premise things, kicking out syslogs, and then you've got the things that we need to pull, application logs, Windows event logs, database logs. We need all of these things from all of those different sensors. So we need a data collection layer that does a number of different things. It accepts all protocols, it accepts both pulling and pushing, and API integration. If you can do that, you're on the right track. Some of them, not all of those SIM tools out in the market can do them. I would advise you to probably stick to the top right-hand corner of Gartner to be able to make sure that you can do that. Next, we need to store the data. Okay, so you probably need a combination of structured storage and unstructured storage. Most importantly, we need to be able to do rapid indexing. It's got to be encrypted so we can trust it, and it's got to have some layer of structuring in it that we can carve the data really quickly. Okay, we layer that up with processing. So the data that's coming in from all of those systems, we've got to parse it, normalize it, we've got to classify it, and the content has got to be enriched. Okay, so that's really important. And then once you've got that, we can start to do proper correlation. So now the business end starts. We've got to have a flexible rule engine that allows us to do all sorts of different types of ruling, anomaly, stateful inspections, all sorts of things that allow us to say, I've got a use case, maybe it's something a little bit complex and business focused. Can we deliver that with this rule engine, okay? And it's got to be able to do that in real time. Machine learning, okay? So we hear a lot about AI and machine learning. I mean, really what we're trying to do is learn a baseline and look at what the anomaly is around the baseline. Forget all the buzzwords. It's as simple as that, and it can be done in a very simple way using reference sets in a sim tool to be able to say, I can learn. I normally log on from this machine. Just learn that, right? So the moment I log on from another machine, we're not saying that that's a security incident, but it's an anomaly. And if I then do, various different, maybe command line PowerShell execution or various different malicious things, then I can stitch those things together. So it's basic machine learning. And then moving on to user behavior analytics. Okay, so SIM tools these days should include user behavior analytics. I don't differentiate the two. The two are combined. Why? Because user behavior analytics should use all of the logs that you've collected in this stack so far to assign a degree of risk to each of your users based on proxy logs, firewall logs, Active Directory logs, endpoint logs, the lot. And we're trying to say, this user has got an elevated risk score, investigate. Okay, it's more of a context-driven thing. It's not necessarily a black and white indicator of threat, but it's certainly an indicator of risk. We then need to take that and be able to meaningfully identify what that all means in terms of alerts and risks and prioritize those, queue those up so I can say, right, this issue is being dealt with by analyst number 1, analyst number 2, analyst number 3 in a prioritized way. And I can go back and audit when someone picked that up, when it was dealt with, how it was resolved. Okay, that's super important. Finally, we need business intelligence. Okay, so all of this is numbers overload, information overload. Okay, you need to boil it back down to be able to visualize to the business this problem. What are we going to do about it? I've got a security posture issue here, and make sense of it in terms of what it really means to the business. If you have a malware incident on an endpoint, the response could be, so what? What's the CIA impact in terms of how it's going to affect the confidentiality, integrity, and availability of my environment? You actually really have to ask those questions. But otherwise, we'll be running around on chasing every small issue. So that's our technology stack that we need to be able to do proper analytics. And obviously, we need people to drive that. Actually, this is where the problem starts. You can build a technology stack, go and buy it. Okay? People are the problem. And it's compounded by the fact that cyber never sleeps, right? It just doesn't. So when you go home at night, we still have the problem. The servers are buzzing away. We've still got access. We've still got users, maybe. Maybe you have a global organization that's got users in multiple time zones. So you have this type of problem. I run a 3-shift pattern, and I know that in a given week, I've got 21 shifts I need to fill, and I've got one person can do 5 shifts. So simple mathematics, I need 5 people to run that, and that's expensive stuff. Plus, I've got to hire, I've got to recruit, I've got to train, I've got to retain. That's probably our biggest problem in security right now. I see a lot of students here today. They're going to be useful in a couple of years' time. Can I retain them? Are they going to be trying to go up the pay grade? Probably. And this is what it's likely to cost you. So I need L1s. I need people, L1s and L2s, that can do the grunt work, the people that are looking, eyes on the glass, responding to things. These are graduates. You're going to pay them between 20 and 30,000, and I need a level 3 analyst who's going to direct those people. Okay? That's going to cost you about 200,000 a year. And the problem is, some will have the budget for that, others will not. And if you're a big organization, you could double this easily. So that's a problem that we need to try to address. Okay? Skill stack. So the skill stack, we need a bunch of things. We need certifications, we need common sense, often lacking in analysts. I can get fantastically certified analysts with a real lack of common sense, can't actually trust them to do consistently what we expect them to do. That's a real challenge, but they need to be able to do a whole bunch of things. So you need to spread of those. Those 5 guys, you probably need to spread those skills across all of those functions. So everything from Python scripting to security analytics, log analytics, maths. Maths is a big thing in terms of what we do in terms of analytics. If I'm doing behavioral analytics, anomaly detection, it's statistical algorithms a lot of the time. So we need a lot of that, and it's often lacking. So we fix that. And there's some great certification programs. GCIH certification for incident handling, GCFA for forensic analysis, even the basics around CompTIA, certified ethical hacking certifications. There's a lot, and there's so many more. There's lots out there. But the point here is that this is an essential component of that skills and people stack. So if we fix that, then we've got an analytics system that's able to consume the information that we're collecting from our sensors. We're able to analyze that. We've got analysts who are able to interpret what that actually means, and then you'd be able to take action, okay? So taking action, responses and reflexes, back to the human body again. The way that we do it, and it can be done in multiple different ways, most tooling has some level of automation. We use IBM QRadar as a SIM tool. We push that into IBM Resilient as an orchestration tool, and we're able to take information that we correlate and we'll put it through an orchestration process to make sure that we can resolve those sorts of things. So we've got being able to create incidents, gather context, isolate machines, and escalate certain things. So that's a whole subject in itself that I'm not going to be able to cover in the space of 30 minutes. But the point is that you've got to move towards being able to get efficient responses to incidents that you identify in your tooling. Simple as that. So what does that look like? Reflexes and responses. Let's start with reflexes. So reflex, the most famous one, is our knee-jerk reaction, okay? So let's put this into IT context. First of all, what happens, wax the knee, we send the information up the sensory neuron to the interneuron. The interneuron sends the information back to the muscles, and your quads contract, and your hamstring muscle relaxes in unison, and we get a kick response. That happens in 50 milliseconds. That's automation. And we need to use some of that automation, but not overuse it. So what I mean by that is something that looks a little bit like this. This is an extract from our security orchestration tool, Resilient, where we're looking at trying to automate a certain response to a certain behavior that we've detected, okay? We don't overuse this. We use this only where we've got certainty around certain conditions, because automation without human involvement can be an absolute disaster. So I get an alert that's coming in. This is a web application attack. It's actually something that we use for a bank who have an online banking system that they're very paranoid about. Zero tolerance in terms of web application attacks. So we pre-correlate that. That's QRadar doing the work. QRadar has got a lot. We've got a lot of correlation rules that are looking for particular patterns of web application activity. So we get a hit on that. That starts a workflow. What we then do is we go and search, have we seen any activity from the same source IP in the last 72 hours? Because if we have, maybe it's a false positive. And can I take the source IP and run it through our reputation check? So we're looking at various different sources for that, from VirusTotal to IBM X-Force, Recorded Future, all these sorts of things. We return, and that takes seconds to do that, okay? So there is a little bit of a delay, because I've got to search something here in a couple of different databases. But if we come back and we say, that web application attack is the first time, I haven't seen that source IP before, and it's an aggressive attack, I know it is, or I've got a hit on a reputation, I will add it to a reference set that will automatically block it. So auto-blocking. Everyone has different opinions on that, but this particular customer wanted it, and it's a reflex action. Okay? Of course, what we then need to do is we need to follow up with analyst work to do the investigation in terms of what actually happened, and do we need to block it, unblock it, and so on. That's a reflex. Don't overuse it, but it's absolutely essential in some cases. What I'm more interested in is responses. The responses are the synchronization of thousands of neurons working together to make a collective decision that we mentioned before. So here we are today. We used an analogy here looking at a footballer. So here's an example of a response. Ball's approaching at pace, being kicked towards the guy at 35 miles an hour, 40 miles an hour, whatever the case may be. The eyes register it, send that information to the visual lobe. Okay, stay with me here. From the visual lobe, sends the information to the frontal lobe that does all of the processing. That's our analytics system here. Frontal lobe makes a decision, I'm going to catch the ball. Okay? He's calculated the rate of the pace of the ball, which direction it's coming in. That's what the frontal lobe does. Sends the information to the motor cortex, then transmits that to the spinal cord. Spinal cord says, move my hands, legs, and everything else. That whole process takes about a second or 2 seconds to do, as opposed to 50 milliseconds for a reflex, which is 20 times slower. But it's a let's say, an orchestrated decision made here, which is based around our actual brains. So what does that look like as an example? Detective phishing incident. All these clever tools will tell you, I've got a phishing incident, okay? Whether it's Mimecast, ForcePoint, Office 365. I'm sure that you have some of these tools, and there's many more. I'm not endorsing them. They exist. So my SIM tool says, I've seen an alert that says I've got a potential phishing email. It needs to be inspected. So what we then do is we orchestrate a response to pull from that email message body, URLs, attachments, the email header itself. So we've got information that we can then go and inspect. So that happens automatically. I'm serving up the information automatically. Gets pushed to relevant reputation sources, and this is orchestrated again, so we have a decision point, okay? So all of this, we've determined that it's either non-malicious or it's malicious, and we take a decision point here, okay? If it's malicious, then the workflow that we have is, we need to inspect it and we need to delete it. A lot of that would otherwise be administrative work where you're going onto a system, you're actually pulling the email, inspecting it, and so on. Whereas what we're trying to do is orchestrate more of a response. If it's not malicious, then we're happy for it to pass, to be released, and it's a false positive. The problem with these tools, they're excellent. All of them are excellent. All of them will give you false positives as well. They'll also give you false negatives. So the point is you're orchestrating a response which has got a bit of automation, a bit of workflow, a bit of human analyst time. And that allows us to make a proper decision. So that is our sort of ecosystem. If we go back here and look at, well, what data do we actually need? Because that's a question that we get asked all the time. We want to log things. What do we actually need? If this is your enterprise environment, okay, then we'd start with the gateways. Always start with your gateways. So we're talking about email gateway, firewalls, VPN, proxy. Okay, so what do we need from that? We need access logs, security logs, audit logs from those systems, and they could sit in the cloud as well. You may have virtualized firewalls, Azure gateways, AWS gateways, whatever the case may be. We need to log those. Absolutely mandatory. Can't do without it. On top of that, though, often gets forgotten, we need audit logs from our databases, because if we're talking about being able to monitor things like GDPR compliance, who's accessing our data and when, I want those audit logs from the database. Increasingly important. We want the server, OS, application, and web logs. It's going to give us authentication, access, audit, application, system security logs. Why? Because I want to look at things like object access failures, authentication failures, authentication successes, new processes starting on those machines, and stitch that together with other parameters around traffic and database audit logging. Okay? We need to throw that in with security events from our antivirus or our endpoint systems. But I would look into this here, Sysmon. Has anyone here heard of Sysmon? Okay, Windows system internals, free to use. I love a lot of the EDR tools that are out in the market, but you can do a lot with free stuff. Sysmon will give you a huge amount of forensic information that you can use to analyze rogue processes, command line, PowerShell executions, and so on. So there's a huge amount of value in that. DNS logs. Okay, if I'm going to exfiltrate data from your endpoints or your systems and databases, there's going to be an element of DNS in terms of covert channel. Okay, look out for that. So log your DNS traffic and look for the anomalies in your DNS. Okay, use of encrypted channels over DNS, unusual queries and source and destination points. Okay, who's got stuff in Office 365 and SharePoint in the cloud and Salesforce and stuff like that, platforms and services in the cloud, right? We're all going towards that. You need to log this stuff as if it was your own. I don't care who owns that platform, actually. You're a user of it. You need those logs, okay? So, we need to look at rogue access, who's making, elevating permissions on those systems and setting up auto-forwarding on Office 365 and so on. That is absolutely required. So that's our hearing. Those are the log sources that we need. There are more, but that's your starter for 10. And I don't think that's so hard to get. If we move back on to looking at the site, we've talked about, you've just gone through a presentation around EDR, okay? So I would urge you to try and think about EDR in terms of looking at subtle indicators of compromise measured against the MITRE ATT&CK. okay? Carbon Black, CrowdStrike, Cybereason, Defender ATP, they're all brilliant. They're all great, okay? But they all really do essentially the same thing. They've got 5% of a difference. What you need basically is to understand where there are rogue child and parent process relationships, unsigned binaries, command line, PowerShell. These sorts of things you absolutely need to know about, in addition to your normal antivirus type of stuff. So map everything against MITRE ATT&CK. If you don't know it, go to the MITRE ATT&CK website. There's a huge amount of learning that can be done here. But the point is that if you have, let's say, a malicious activity, you might have a peppering of various different indicators across all of these groupings here. And that's really the point of EDR, is that we're not explicitly trying to find one bad thing. We're trying to collect a lot of things together to imply a rogue activity, okay, that has potentially evaded all the other tools. So that is probably an essential point. And there's lots of different ways on how you're doing it, okay? So we don't all have huge budgets, so maybe you don't have the ability to buy it this year. So there's things that you can do, okay? So obviously there's compromises that you need to make. You need your traditional antivirus. I think we've probably all got that in place, okay? But what we would overlay in terms of an EDR capability on top of that is being able to say, I need to detect behavioral matters. Like I said, the unusual processes, suspicious binaries, IOCs, be able to do some threat hunting. And I would like to be able to do some machine isolation, hash banning, and so on. So how can you do that on a bit of a shoestring? You might have some of these tools, some of the traditional things in place at the moment. That's great, okay? And there's lots of others. I'm not endorsing any of these products. There's lots of others. So what you can do as a starting point is you can download the Windows sysinternals. You can pull out the sysmon module. You can push that out as a group policy change. It's not intrusive at all. And then you can build up a bit of a library in terms of PowerShell and command line scripts that allow you to kill processes that are executing, isolate hosts, and so on. That is your cheap man's EDR. Costs you a bit of time. Actually, there's a huge amount of information out there that allows you to do it quite quickly. And you can log all of this stuff, okay? So I'd urge you to have a look at that before you go investing in very expensive tools. Of course, what you can also do is you can overlay just an EDR component on top of your antivirus. That will give you that information, okay? So that can be a cheaper way to do it because the rip and replace with the next generation endpoint solution can be really expensive. But if you've got the budget, great. You can do that as well. Maybe it's the simplest method of all. So like I said, I'm not endorsing any of these products. There's a lot of good stuff on the market, but there are 3 different strategies, and I've seen all of them work. But the point is, you've got to sort of believe that you really need to see this type of activity. Smell, okay? If it smells bad, it is bad, maybe. Network analytics. This is a bit of a tough one because there's some really good stuff out there as well. So let's start with some of these types of vendors, your Vector's, Darktraces. There's others, okay? What they're doing is basically looking at the anomalous machine activity based on algorithms that are saying this client-to-server relationship is unusual because of X, Y, Z different patterns of activity. It's trying to imply, based on pure network analytics, what's bad. And it can do that. And I've seen that if you get breached, there will be a Darktrace log or a Vector log there, okay? But at the same time, they also generate a lot of noise. So it's information you need to be able to consume. You need to be able to prioritize and correlate further. They require further correlation. You can't just use these tools. If you go along with me that this is a sense of smell, because you're not actually seeing the actual end problem, okay, you wouldn't want to walk around the streets of Manchester just with a sense of smell and no visibility, no hearing. You take hearing and visibility first, would take smell third. But there are alternative ways to do this. Like I said, I like these tools, but you can start in a very cost-effective way. Open source tooling like Moloch for looking at index packet search and capture, and Snort for open source IPS. It is still the biggest library of IPS signatures out there. Cisco bought SourceFire, but that's a Snort engine, and there's a huge amount of intelligence you can build on the back of that, and it's going to cost you nothing. Okay, you can get the supported version. I think it costs about £500 a year. So that allows you to do a certain amount of network analytics. All right, you have to look at how you deploy them. There's network encryption issues, which give you lack of visibility, but you can start with these tools. So I would recommend you entertain some of those things. Finally, the sense of touch. Okay, so here we're talking about the context side of things, and there's a lot of things I'd put into context, but if I was to boil it down to 4 important things: high confidence intelligence. Okay, open source intelligence is fine as a starting point, but don't rely on it. There'll be a lot of false positives. You've got to find a way to curate your own intelligence, and I'll show you how. Asset and vulnerability data, that's intelligence, okay? If I know I've got critical hosts that are vulnerable, that's intelligence you've created internally that you can use as context for monitoring. I can group those into critical assets that are vulnerable against certain type of different attack parameters, okay? But you've got to have that information. And if you don't have that information, you're kind of blind internally in terms of how to prioritize those. User behavior analytics, I've mentioned that previously. Being able to identify a risk-based scoring per user, that's context. That's using the information that you've harvested and creating a risk score per user. But this final one, I think, can give you a huge amount of value: business service profiling. So what this means is you've got your HR systems, your billing finance systems, your CRM systems. They're traditionally built from component parts. You've got to model those as a system and look for what's unusual about those, okay? So breaking these things down, how do we get high confidence threat intelligence? Okay? You can go buy it, or you can curate it. I would urge you to start by curating your own intelligence. So you can do simple things. Your firewalls will trigger signatures, okay? That is high confidence alerts saying that this source IP is bad for me. Collect that IP address and add it to a list, because that is specific intelligence for you. Okay, so the whole idea around intelligence is you want to know who's targeting you. It's interesting to know who's targeting someone in Australia, but there's a lack of relevance there. It's interesting, but a lack of relevance. You want to curate intelligence based around you. So take it from your tools, harvest the source IPs, and keep it in a watch list. Discover threat actors who are seeking you out by name. Okay, so one of the pitfalls that everyone falls into with SIM tools is you start to see reconnaissance activity on your external firewalls, and 95% of that is universities scanning, Shodan, free to use scanning tools, which we can't stop, we can't control, aren't necessarily a threat, but you can curate your own intelligence by saying who's seeking me out by name, because that is an entirely different thing to reconnaissance. Okay, and I'll show you how to do that. So you can start by spinning up some fake subdomains, give it a real DNS entry, resolves to nothing. Okay, so if you were to do this, this is our domain, siconsult.com, and we have spun up a bunch of fake subdomains here, VPN. Dream up, whatever you fancy. Have those in place, okay? And then if someone is trying to discover those, they're trying to seek you out by name, not by IP address, okay? Shodan will discover you by IP address, but it won't discover you by name. So if someone is seeking you out by name, it's proper targeted reconnaissance, and you need to collect that information. And this doesn't cost, and I'm telling you a bunch of free stuff, it doesn't cost you anything to do. Okay, it takes a little bit of hard work. So, of course, you can buy tooling that help you do that. But if you integrate this to be able to collect, what are the vulnerabilities that they're trying to exploit, what are the source IPs, that telemetry you can feed into things like open source intelligence stacks like MISP. You can download that today. That's free. It allows you to harvest and collect IOCs, and then you can feed that into your tools. So I see someone trying to connect to OA.SI consult. I can feed that into my SIM. I can feed that into my spam filter. Block this IP address. Okay, it's proactive things that we can do that we can respond to that. So TI honeypots. The next one is asset and vulnerability data. So I think most of you will do some form of vulnerability scanning. Take that information, but also we need to add to it in terms of identifying criticality, how we're architecting our environment from the subnetting, the locations of vulnerability, and so on. I think that's kind of understood. But if you don't do that, you're absolutely blind to that internal context. And then user behavior analytics. So who here is using any sort of UBA tooling? use behavior analytics, okay? Really useful stuff, data science really. And it's an important overlay. So what I get to be able to do here is I'm able to rank my top risky users. You can start off just by reporting. So on a daily basis, I want to have a look at my top 10 risky users. Who are they? What have they actually been doing? And maybe the output of that is not a sort of conventional, we're going to block someone or we're going to shut them off, but we're going to do some security awareness training about what they're actually doing on the network. And your objective is to reduce the user risk, okay? Once you've reduced that down to a point where you've got let's say, less noise in the environment, you can then start to use it for actual alerting on and investigations. But absolutely, critical context, okay? But this one will bring you probably more rewards in terms of actually identifying business risk, okay? There needs to be a so what discussion around security incidents, okay? Because you need to identify, you can find out a bunch of things, all right? My average customers probably are logging around about 2,500 events per second as an average customer. Among that, there's going to be a lot of noise. There's going to be a lot of alerts, and a lot of them are going to be important. A lot of them are going to be, questions around, is it something I really need to chase because I've got a bunch of other things I could be doing? If you group your assets into business services, so this could be your CRM system, your student information system, your billing system, it doesn't matter. It's comprised of databases, application servers, web application servers, group them together. So what I'm interested now is, what are the normal processes that are running on those systems? What's the normal outbound communications, the normal authentication, normal backup, admin, all of these sorts of things, you start to model that. So I collect this information over a 1 month period, and if I see a new user or if I see a new outbound connection from that system, I'm no longer talking about a particular host. I'm talking about, I can see outbound communications from your CRM system to a new IP never been seen before. That's a different risk discussion to talking about a particular host that no one knows what the system is that it's grouped by. So business service profiling allows you to have a conversation at a more of a management level in terms of risk profiling across the business. So have a look at that. And there's some basics. So I've gone through some things that can be done quite quickly. Some of them low cost. Most of them are technique-based, all modeled around the whole idea about we've got to get the right data sources in, our sensors, we've got to have the right analytics engine in there, but most importantly, be able to conduct the right responses which require a combination of people, process, and technology. Any questions? Nope. Okay, well, thank you very much.